Hello everyone. So today we are solving another question of JEE ADV 2012. This is from the topic of electrostatics. So let's read our question. So let's consider there is a thin spherical shell of radius r with its center at the origin carrying an uniform positive surface charge density. The variation of the magnitude of the electric field and the electric potential with the distance r is best represented by the which graph. Okay. So let's try to solve this question. Let's first imagine, let's say this is our sphere here. Okay, and we want to measure electric field and voltage as the or the potential as the function, okay, with the distance here. So to prove this, I will use some Gauss law. Like, you know what is Gauss law? It says that the net flux through an enclosed surface through a Gaussian surface, it is equal to qi epsilon naught. And what is flux? It is nothing but E dot dA here. Okay, so if you see here, if I make any kind of Gauss surface, okay, so what will be its area? It will be nothing but 4 pi r square. So E should be equal to technically Q enclosed by 4 pi r square times the epsilon naught here. But you can see, we know that when there is a round surface charge here, so we assume its center, like a point charge is placed at a center. We assume kind of thing to solve outside the surface here, because we can just like a center of mass, we like to make it simplify it, we assume that a small charge q is at the center here. But here absolutely there is no charge in between this surface here. So you can make any kind of surface inside and there will be no charge here, which means the E will be always will be equal to 0 inside the radius here. Okay, so which you can see in option, I think A here you can see, and option D you can see. Rest of they are showing that constant electric field here, which seems to be incorrect. Okay, now moving further, how does outside work? I have told you just when it comes to the outside, we assume that the whole charge is placed at the center and we measure it as like a normal Coulomb's law, that is kq by r square is the magnetic field here. Okay, which means like both graphs are satisfying for that. Now moving for the potential here. What is potential? Basically, from the formula or from the laws, we know that the electric field anywhere, it is equal to minus del V by del R. That is, V should be equal to sorry for that, V should be equal to E dot dr, whether the sign doesn't matter here, positive or negative. But you can see, since E is 0 here, sorry, not V, it should be delta V, which means that there is no change in potential inside the surface because there is no electric field here, which says if there is any kind of potential, it will remain constant in between the like complete surface or the inside the radius. So which is shown by, I think, our option D. See, it is showing that the potential is constant and then it is moving radially, like it is basically it should be equal to kq by r, that it is basically the potential here. So you can see that here they are showing a linear relation, which is incorrect because everywhere inside a shell, the potential is constant here, not the directly proportional. So which means our option D is correct. And like this is a very like illustration type of question. You should always remember that for a shell, electric field from 0 to R is equal to 0. Okay, like R is nothing but the radius here, and E from R greater than R is equal to nothing but kq by r square. Similarly, for the potential from 0 to R, potential is nothing but it is equal to kq by r. Q is nothing but the whole charge here. Okay, and the potential kq, sorry, not small r, it should be capital R. It is constant with a radius. Okay, and V for R greater than R, it is equal to nothing but kq by r here. This is the formula and you must remember it to quickly solve this kind of questions. Thank you everyone.